Alright, it's been a while since I've done an update on the Edison restoration. The problem is time, finances, and knowledge. And I'm not working on one, I'm working on the other. So what we have here is an Edison A10. It's one of a little over 20 I bought for about $3,000. The seller included these cables, which unfortunately, as you can see, they do not match up. The hole is a little too small, right? Which is sad because these are pretty nice and thick, heavy duty. I think they're welder's cables. So I basically had to think, how do I drill out that diameter, or should I just say the heck with it and find out what that hole is and try to substitute a larger diameter hole. So anyway, the original Edison nickel iron battery cell connectors, they were copper with nickel plate on them. And I don't know if you can see. Let's see. I used to think they were solid nickel. Then I did some history research, and nope, are copper, solid copper, nickel plated. So anyway, I was trying to show you the copper there. Now what I think would happen here is the prior owners of this battery set, they tried to disconnect the batteries, found some were either sealed or welded on or corroded on, or whatever you want to call it, and so they just ended up cutting off the terminals, which is too bad, because they're a custom tapered connector. If you look closely, you can see there's a taper. It's smaller on the top, wider at the bottom. And so the connector is a custom job. The nuts, and I will say this too, the different batteries had different sizes of connectors and terminals. So for the A10, this is one of the larger ones that they made. So my A6s and A4s, they use a smaller version. So anyway, the nuts are also custom. I took one into Ace Hardware. I was like, hey, can you find out what diameter this is? They had a lot of trouble. They said, oh, we've never seen anything like that. So these are steel, nickel plated. Kind of see some of the nickel plate still there. But anyway, I found some wing nuts and stuff that they're not exactly there, but they're kind of there. They at least come down enough, and I can do the rest with copper washers as spacers. So anyway, we found the guy that sold me these batteries. He wanted to sell me these connectors too. He must have known that they didn't work. He must have tried them and said, "Oh, these are the wrong kind." But he sold them to me anyway, and I didn't want to argue because figured I'll remedy the situation later on my time and my dime, and not during negotiation. It's really hard to get a hold of these. So anyway, we got a bunch of these things. They're just about right from lead acid batteries. And if I go build another bank of lead acid batteries, I'll probably use those. So anyway, turns out military surplus to the rescue. These, I think, were pretty sure These were used on Abrams tanks. Not too sure, kind of sure, I'm not sure. But Abrams main battle tanks. These are surplus terminal connectors from the military. They're pretty expensive, over $10 a piece, and I needed to get quite a few. So, because I'll be connecting about 20 batteries, I estimate, depending on my skill in restoring them, for 24-volt system. So it turns out, guess what? I've already tested this, so I know already, but it goes on just fine right there. And so, about $250 for a bunch of these military surplus cable connectors. They're anyway, thought that'd be interesting to show just the intricate details and problems a person runs into. I think I will develop my my proposed encyclopedia of Edison nickel iron battery information. I've got quite a few more materials. What I need to do is organize it and put together and put some commentary in there, and I might have that up by next year. We'll see. Talk is cheap, right? But I don't know who it's going to help. It's like trying to sell a book or something on how to restore like some rare car that almost nobody has. I mean, I don't think it'd be very valuable to the general interest, but might as well do it anyway. Save someone the trouble of having to research all this stuff themselves. So anyway, all this theatrical looking horribleness is kind of a solution I had. I've had terminals tweaked by shipping, and I told the seller, hey, why don't you use some sprayable foam and foam up the end so it'll protect the batteries and shipping. And he was able to get that done, but unfortunately he didn't do it enough to where the foam stayed where it needed to go. It actually leaked out of his whatever system he had and adhered to the tops. And I had the worst trouble you ever saw trying to excavate them. And this is mostly done. There's still a little bit more to go, but I had over 20 of these things to do, so that took forever. So I'm going to clean this up even more. And especially the terminals where they need to have electrical contact, and clean out the carbon out of the that's the other deal with these. They're always carbonated up. I'm going to clean all that out meticulously. It's pretty much cleaning like carbon out of a receiver for a machine gun or something. Trust me, it's almost the same thing. Except you can't have any of that carbon dropping back into the container here. You got to do it all upside down. So there is a lot of extra irritations and things that go into getting a set like this going. And I found some original manuals, of course, but I also found some technical publications. And the whole question about what was the purpose of lithium, according to these books, I'll probably do another video on that. The lithium is pretty essential for 10 to 15% more power and more cycling. over the lifetime, and that's what I'll come up with a book and show it where it says in there. So I might have to, well, I will have to like revise my idea of just going to have potassium hydroxide and distilled water. I'm going to have to add lithium to that. But the problem with that too is some of these batteries have little pinholes of rust. Now the case, it's important, you know, it needs to be intact. But I think I can use this product here, and if I do it right, I can seal up some of these pinholes that are in these cases. Some of them little pock marks and stuff. Pretty sure I could use this. Reason why I say that is this product is used on radiators for vehicles. Now it gets really hot and chemically and stuff, so I'm assuming it would be the same, almost, maybe not as hot, but of course not as hot, but I'm saying if it can handle radiators, it might be able to handle a Edison nickel iron battery with alkaline electrolyte. So yeah, what else can I say in these last moments here? Well, you can look at this nut, and I think it's been tweaked or corroded or something. It looks like it's been tweaked, like someone really tweaked it trying to remove it. So I might have additional issues. Well, I really will probably have additional issues taking this nut off and taking this connector off, because it may just be sealed on there, whether it's tension, whether it's corrosion, whether it's welding from high arcing and sparking, or whatever it is. It can be sucked on there. I won't be able to get it off, and in that case I've got to find some kind of workaround. Whether I clamp to here, we'll have to pull this up a bit so it doesn't touch the case proper there, but pull this up, and this is pretty heavy duty. It takes a minute to pull something like this up. Put a clamp on there leading to another terminal for another battery. Just all kinds of workarounds. And then position wise, think about it. Like, this is the right size, 3/8 inch, 3/8 inch, right? So that goes on there. Think how far it has to go to the next battery, and then imagine 20 of those. That's going to be a huge amount of space taken up. So where I'm going to locate that's going to be another issue. You know, these generate hydrogen, which is interesting for me because I'm trying to get into getting some hydrogen fuel cells going that I have. So, but capturing hydrogen out of one of these and then having it pure enough to go to a hydrogen fuel cell and the storage and all the complications, that would be that would be probably half a decade worth of intense work at the rate I'm going, because I only have a couple hours every week to throw it, stuff like this. So let's say it can't be done though. That'd be pretty slick if you had nickel iron batteries. Maybe have an automatic watering system of some kind, but then the hydrogen generated be collected and that goes to a fuel cell. That'd be pretty slick. Ian Sotar, I guess, I think he's still bumping around in Canada, but he is a big Edison battery advocate. He said that you could put what do you call a cap on here that would combine the hydrogen and ambient oxygen back in the water, and it drip down like through catalytic action. It was one of those expensive metals. That's what I need. I need like a periodic table like here. What I really want to have, to be honest, is a periodic table a picture or a diagram of the electrical connectivity of metals, and then like a chart of the hardness of materials, like material hardness, maybe like a reactivity chart, like different charts and stuff. I'd love to have that so I could just say, okay, it's going to be this, it's going to correlate with that and transduce into that, you know, like have like another chart saying if you mix this and that, it'll create something else, you know, reactions and contraindications and things like that. That's what I need, like a flow chart, because to retain all this information, it gets displaced. I'm telling you, going to university and stuff, you gotta prioritize your brain space, and I'll tell you, it's a lot of the good information I know by heart goes away while I have to study for cram for exams, right? So anyway, what was I saying? Anyway, if you're interested in those caps, look up Ian Soter and his nickel iron caps. You can do a Google search. Really sad I can't think of the metal. Platinum. Yeah, I think it was platinum. Platinum caps. I guess Ferraris and things like that have platinum caps on their batteries. It's like a premium option, and it helps recombine the water, recombine the exhaled vapors and stuff back in the water, so they don't have to water the batteries so much. And they use lead acid batteries like Ferraris and high performance vehicles. So that's where the platinum cap came from, I guess. I think, or unless Ian Soter invented it. And then you can just take that technology and go over it with nickel iron. Now there's a bad secret about these things. It was a secret to me I didn't know about. And I might get to that in another video. So if you're interested, you better like and subscribe, because it needs some motivation for the because I'll tell you, some things, I don't know, part of me is like, oh, everybody should know, but part of me is like, you know what, I go through all this trouble and like nobody likes or subscribes barely, so to me that means like, well, maybe I should be a little less forthcoming with things, huh? Anyway, prove me wrong if you want, or not, just be yourself, either way. So what else? Oh yeah,